First of all, let's assume that we have an electric field, a uniform electric field. And so the electric field is directed to the right here and is equal to 641 newtons per coulomb just to the right. And let's now say that I have a cylinder. The cylinder has some radius r and some length L. So let's say that r is going to be 6.5 centimeters, and let's say that L is 35 centimeters. So we have a couple possibilities I want to consider. I want to consider the cylinder sitting like that inside of the electric field. So I now want to know what is the flux into the end of this. Okay, well, the flux into it is going to be E times A. So it'll be E times pi r squared. So there'll be 641 newtons per coulomb times pi times the r, which is 0.065 meters squared. So the flux around just into the end of it is going to be equal to 8.51 Newton meters squared per coulomb. Well, let's consider another orientation. Let's now consider that I've got it like that, and I want to know what's the flux into it right here. Okay, well, if you look at it, cross-sectional area, so if I put my eye right there and look at it, then what am I going to see? Well, I'm going to see the electric field going away from me, and I'm going to see the cylinder look like that. And so that dimension right there is 2r, and that dimension is L. So the area is going to be 2r times L. And so the flux, which is E times A, that flux is going to be E times 2RL. So the flux will be equal to the flux is going to be equal to 641 newtons per coulomb times 2 times 0.065 meters times 0.35 meters, and so the electric flux into the side, so that's going to be 29.2 Newton meters squared per coulomb. Okay, so what we had here was we had a uniform electric field, and depending on the orientation of our cylinder, we got a different answer for the flux into the cylinder. Now, what about the flux out the other side of the cylinder? Well, the flux out of the cylinder, because the electric field is going in and out, then it's just going to be negative of the flux. I mean, so the flux out is going to equal the flux in, and so one's going to be positive, one's going to be negative. And so we'll investigate that in our next video. But technically, what I should have done in my previous examples, what I should have said was that the flux, through the end should have been written as negative 8.51 Newton meters squared per coulomb, and the flux into the side should have been a negative 29.2 Newton meters squared per coulomb. Flux in should be negative, and flux out should be positive. Okay, so this is our definition of the sign of the flux. Negative or positive should be whether it's in or out. So now I'm going to do another example.